Nice.
Cool.
Cool.
Awesome. We will wait just 1 minute, and then we'll start here.
Sounds good.
Awesome. Okay.
Awesome.
Okay. Well, I hope everybody's doing okay. Thank you for coming to, this is sort of part 2. We have a part 1. It's on our YouTube channel, and it should be posted and everything. So if you're unfamiliar, you can check that stuff out. But really, a prerequisite for today is you probably just should have a little bit of knowledge of Git. But if you don't, we do have some review and everything too. So yeah, I'm Gavin. I'm the GDSC lead for Conestoga College. I'm in the Bachelor of Computer Science program. And I'll let Emil introduce himself.
Hi, everyone. My name is Emil. I'm also in the same cohort as Gavin. And yeah, so Bachelor of Computer Science. So cool. And I'm a core team member.
Awesome. So today we will start off with a bit of a review of last workshop, and we will sort of intertwine that into today's topics. We'll talk about the difference between a fork and clone. We'll do some merging, and we'll also discuss some Git strategies and different practices, and then end it off with discussion of GitHub tools. If at any point you have questions or anything, feel free to drop it into the chat, and we will try and answer it as we go or at the end, if that's more appropriate. Awesome. So just as a review from the last event that we had for Git and GitHub, we learned just the basics about sort of what it is and the key commands that are used to make sure our code is saved. So just starting off with a few key things that we got feedback on or had questions about. And so files can be blocked from commitment using the .gitignore file. And you can just create a file right in a in your like working directory called .gitignore, and then add files into that. And then anything added into that file will be blocked from your Git commit. As well as branches. There is some confusion on that. So branches are, again, used to collaborative work together almost asynchronously, and it will help to mitigate code conflicts as if you're working on it at the same time. We'll get into this a little bit more later on in the event here. So just a reminder for the key commands. So looking in the local repository, which is basically our system, in the working directory, we can type in git add into a terminal, and it will add any files that were modified, like created, or even like deleted into the staging area. And so the staging area is sort of like a snapshot of your code. However, it's not saved. We can use the git commit command to go ahead and save that into our local repository. And so that is essentially like a version control or like a save, like in a game. And so if you make any changes, you're able to go back into that commit. Now, where GitHub and Azure come in, they are remote repositories. So if anything happens to your computer, like it burns up in a fire or something, that repo is on your hard drive, so it will be missing. And what these remote repositories do is allow you to effectively have like a cloud save of your code. And that's what git push does, is you can push your local repo to a a remote repo there. Now, any changes that happen on that remote repo, say someone else does this git add, git commit, git push on their system and updates a file, we can get the new refresh or the new version of that file using git pull. And that pulls it from the remote repo into our repo, our local copy. And then we can go ahead and do the whole cycle again, git add, commit, push, all that stuff. Now, just as a note, when we're in the staging area, and let's say we want to go back, we missed adding a comment, or we see like an issue was raised or something, and we have to like fix something before we commit, we can actually use the git reset command. Yeah. Awesome. So fork and clone. So I think we talked a little bit about clone before, but clone is essentially downloading a copy of the repo from like GitHub or like an external repo or a remote repo, sorry, I should say, onto your system. What it sort of does is it like downloads like sort of like compressed version, and then we'll open that up. And so it just saves you a lot of steps from downloading it manually, clicking extract, extracting it, and it sort of sets up your environment as if it was like what's shown in the repo. So you'll probably end up cloning things like almost like 90% of the time, I'm sure, when it comes to like sharing projects and everything. Now, fork is a little bit different. It does sort of the same thing as clone, where you get to have or like copy a repo, but it is sort of like a GitHub or Azure or like a remote repository feature. I don't think, Emil, you can chime in here. I don't think, yeah, okay. I don't think it's a like a Git sort of concept. And what it does is allows you to basically have a carbon copy of the repo, but you're able to make pull requests onto the original repo. And so where this might be good is like open source projects, or if you, let's say I have a like a template or something, and you want to fork the template, build like this application based on the template, and let's say you want me to implement it. You're able to make a pull request of your repo onto my repo, and I can accept it. So again, this is not used as often as clone, but we thought it would be good to mention. And we'll be using it today, actually. Awesome. Just talking about merging, because I think it was sort of a big concept to learn from last event that we had. So if we remember, we have branches like main and feature can be anything that we name it. But our master or main is basically like the, well, exactly what it sounds like. It's the main sort of version of our code. And so we can see here, M1 is a commit and M2 is a commit. And let's say I make a feature. I want to implement this microservice or something into the system. Instead of committing my code and saving my changes on master, I can make a branch off of M2, name it feature, and then work on that stuff. And what this allows me to do is if this microservice or something doesn't work out, I'm not ruining the master branch. Or if we want other code changes or something based on feature, we can actually branch off of the feature instead of the master. And it allows us to not interfere with other code that is going to be implemented or added on. And it almost like asynchronously allows us to collaboratively work without like worrying about if someone is going to go in and change your code. It's all on you, right? Yeah, so I see that there is a question here. What happens to a forked repository when the original repository is deleted? That's a great question. Maybe Emil can help us out there. Do you know?
Yeah, I do not know. I'm imagining it will just be like the fork will stay, will still exist, and the original repository will just be gone.
Yeah. Be like
Um,
unlinked, that sort of thing.
I will just quickly Google it. I'm sure it's original is deleted. Um, blah blah blah.
Oh, all of its private
Oh,
works are deleted.
yeah. If you remove a person's access to a oh, this is a public repository. Oh, one of the existing public forks is chosen to be the new upstream repository. So basically, it's kind of like feudalism. The king has died. One of the children or forks is elected to be the new original. Um, so is
This is
that
interesting. Yeah.
interesting? Yeah, I'm
That is
sure
a good question though.
that is a very good question. Hopefully you don't have to ever deal with that because I would not want to be the original repository.
Yeah.
Um,
Just coming back here to merge real quick. And so our sort of string, or I shouldn't say string, sorry, timeline of commits here with master is when I merge my feature onto master, we'll get this sort of straight line of M1, M2, F1, F2, and then M3. And that's because I merged off of M2, so my feature stuff will be pushed and fitted like right into there. It's kind of hard to describe without without practice and stuff. But yeah, we'll be doing that today.
awesome. Yeah, and speaking about forks, we'll get started with our demonstration. So this demonstration will kind of continue along as we go through it. So we'll just start with the very first step, which is forking a repository. I'm going to, oh, I think Gavin is going ahead and he's going to
Yes.
copy the link to our repository that you can fork. I will have it up here. So go to that address. It should look like something like this. And then you will go to it and you'll see my little face over there. And that's because I am added to this repository. So I'm one of the contributors. However, probably you, the audience, aren't contributors. So you won't be able to make changes to this repository. But that's okay. What we can do is fork it. And you notice if I put my mouse over fork, which is on the top right of the screen, let's say that it creates your own copy of this repository. So you can really, yeah, so really think about forks as just like a copy of the original. And so when I'm creating a fork, you can see that the owner person is now me, right? Before it's this GDSC Conestoga, which is actually like an organization, but you can think of it as like another user. This is their user's repository. Now I'm creating a copy of it on my account. And you can see it can copy only the main branch if you want. I'm going to choose to do that because it's ideal. But you can see like because it's my copy, I don't really care about what branches they have, right? I just want to get the main branch. So I'll click create and GitHub will do its magic. You'll notice that we are forking the repository on GitHub, right? Because it is a GitHub feature. It isn't found from Git. And now you'll see it's done. You can see that this is my repository and it was forked from that repository. So that is forking. And yeah, and so now this is my repository. It says I literally own it. So
Yeah.
cool.
Yeah. Feel free to follow along. Sorry, I don't know. I don't know if we mentioned that. But yeah. So you want to
Yes.
go to that link, click fork, click create, and then you should be able to have, or like you should have that repo forked on your GitHub account.
Okay. Yeah. Sorry for not making that clear.
No, it's all good.
Okay, so now I'll actually be explaining a few more things. So if you hadn't been following along, but if you want to, you have time. But anyways, what I'll be talking about is Git branching strategies, or in other words, how should your team use Git? We've talked a bit in the last workshop and even today about some different commands, but really, how do we use these commands and how do we put them together? Well, there are several strategies. A Git strategy is kind of like a shared like procedure that your team has decided to use Git, right? Because it is very flexible. And these strategies will balance like the ease of use or like how easy it is to use that strategy and like the level of organization. it provides. And some examples of these strategies include trunk, Git flow, GitHub flow, and GitLab flow. I won't talk about any of these in really any detail, but you can Google them. And what you'll find is that they all more or less do similar things. They just, might have different timelines of when kind of things occur. So they are very similar, and it is again balancing that ease of use in the organization. And when I talk about organization, I'm just talking about like, you know, how easy it is to like undo changes and stuff. These are getting to be pretty advanced concepts, right? So that's why, like for me at least, I use like a very easy strategy because I don't really care, right? And I don't want to deal with like the hard to use things. But you can think about like a big company wanting to like specifically audit and making sure they know who exactly is doing a particular commit or a particular feature, for example. So let's not worry about how like big companies use Git. Let's just talk about us, right? How should we use Git as a team? Um, what I'll suggest is just one, always develop on a branch, like don't develop on the main branch, I mean. And two, keep that branch as short lived as possible. And I think those are just two rules that if you just follow them, you should be okay. So when do we create a branch? Well, it's really anytime you want to like do some work, right? And this branch is going to represent a piece of work, right? So what do I mean? Well, maybe if I'm just adding one function, that can be its own branch. And that branch is all about adding that function, or maybe even just changing one function. You can even think a little bigger. You can think maybe like a login page, right? So this branch is like everything to do with logging in. Before, before this branch was made, there was no such thing as users. And after this branch is made, there's now a login page and I can log in as, the test user, right? So maybe that's a branch. It's a little bit bigger, but you can still think of it as like a short, small, well-defined piece of work. Um, After you created that branch, you obviously want to work on that branch, but you want to do so for a very short of time amount of time. It kind of depends on like how big your team is and that kind of thing. Um, but you don't want to like have a branch that you create and then a bunch of other changes happened in the background that you weren't involved in, and then you finish your branch because you can think of all that big massive changes that like other team members did and so forth. You can think of like every time someone's making a change, that's just one more risk that you're going to get a very ugly merge request that you have to deal with. So you really want to work on that branch for a short amount of time. And after you're done, you want to create this a thing called a pull request, which we'll talk about later, but it's just a way to merge your changes into the main branch. You want to create a pull request soon, right? Uh, and sometimes you might want to try to find a natural stopping point, right? In other words, change your plans. Maybe you were trying to make this branch, add a whole login page, but you weren't able to like finish it in a day or so. Maybe try to find a natural stopping point that's, kind of like it's still a little incomplete, but maybe the code isn't active, right? So you have like half of the code quote unquote needed for the login page, but like in your main code, you just never use it, right? You never include that login page, right? So it's kind of like dead code hidden in there. That's okay. It's not ideal, but it's better to do that and create the pull request and deal with an easy merge and finish your login page later than to, take another week or so and then finish your login page, but now you're spending another week dealing with a merge request or something. And the last step, of course, is to repeat. And repeat it a lot, right? You may get surprised with how often you're creating branches. Like I certainly was. And that's okay because each branch is a small amount of work. And, it using the branches frequently and often means that everyone can develop without having to deal with, um, you know, merging a lot of changes. Because each time you merge a lot of changes, it is tends to be quite error prone. So let's continue on with this demonstration. Hopefully everyone was able to fork the GDSC repository. If you weren't, please let us know. But we're going to go ahead and make a branch. Now, the first thing we need to do is to clone this repository. We can make a branch here, but I'm going to go ahead and use the GitHub desktop thing. I have GitHub desktop here. open. And so I'm just going to go ahead and click add, click clone repository. And then I'm just going to type in ehharvey / and it's like Git and GitHub Conestoga 2023. And I'll click OK, and I'll click clone, and it should be OK. I'm just going to click continue. So that was cloning the repository, but actually those slides said to create a branch. So you can notice up here, I'm on the main branch. And that's because that's the default one, but it's also the only one I can choose from. So if I go up here, I can click new branch. If you don't have GitHub Desktop, I believe there's a git branch command, but I'm using the desktop. So if you're not sure, please let us know and we'll look up the command necessary. But it is something that's pretty easily Googleable too. So I'm just going to call this branch anything I want. I'll call it. Sometimes it's good to name the branch after like the type of work you want to do. So I'm going to say it's going to be add text file with my name. Very long branch name, but it's very descriptive, so it's not too bad. So I've created a branch. Right now, we haven't done anything on the branch. Nobody's updated the main branch. So this branch, this add text file with my name branch, it has the exact same content in terms of like what the folder looks like as the main branch. No changes has been made. Awesome. We have made a branch. Please let us know if you're having any issues with this step. But otherwise, we're going to move on. We're going to do a change. We're going to make a change, add a file. That's why I named that branch, make a text file. So I'm going to go back here, and here is my repository. I'll open up this. This has my repository as well. And I'll go ahead and click new, and I'm just going to make a new text document. So one thing to know about Git is that you don't like need any tools to like work with the files. You just add and remove files. And the text file should have my name. So it's Harvey, and I'm going to open it in add. And I'm going to make it like a little hello world, right? Like hello world, if you don't know, is like a thing, like a typical exercise, like, think school problem of like your very first program. So you make a website that says hello world. Today, we just make a text file that says hello world. I'll save that and I'll close it. And so now we've made a change. And you can see GitHub Desktop is very convenient, and it'll just show us the one change file. But right now, I haven't committed it yet. So it's Git doesn't really know about the change. So I'm going to go ahead and commit it, because committing is the first step to getting the changes onto the GitHub side. So you can see that Git or GitHub Desktop more specifically has given us like a placeholder name, and I like that. And I say this is for the workshop on 2023. GitHub Desktop has this to like create the name and put a description, but it's actually like the same text file. It just GitHub has this weird format. But if you're just making a commit message, it's literally the same thing. GitHub Desktop just shows two text boxes. So I'll click commit, and now the changes have been committed. If I go to the history here, you can see this is my create emilharvey.txt. So this, what I'm showing right here, this is one commit, and it's saying in this commit, I made a new text file that says hello world. So it's committed. My computer knows about it. But remember, when we talk about committing, we're talking about committing to the local repository. So if I go here and I refresh, like I won't even see the branch because the branch doesn't even exist. I have to publish my branch. So I'm going to go ahead and do that and publish branch. And you can see GitHub is so quick to notice. It doesn't see the branches here, but if I refresh, we will see my add text file with my name. I believe I actually just skipped over a few steps, so I do apologize. So yeah, I just did the push change to GitHub repo, right? So what I really want to emphasize 1,000 times is we are pushing the change to the repo, right? This step here, we committed, but it committed to our own like desktop or laptop or whatever. But when we talk about step 4, we are taking the repository on our local machine and we are pushing the changes to the GitHub repository. So hopefully that makes sense. I know it's kind of like extra, but it is a very important thing to think about, especially as you start to run into problems with Git and GitHub. Now we talked about merging. We haven't done any merging. We just did a commit and a push. So what's next? Well, what we're going to do is take a bit of a detour and talk about pull requests, because pull requests are a thing that is very related to merging. So what a pull request is it basically it's a thing in GitHub that represents when you want to take a non-main branch and you want to take the changes in it and merge it with the main branch. So in other words, you make a pull request when you're adding finished changes to the main. So in my branch, it was the add text file with my name. I added that text file. It has my name. So now I'm going to be ready to make that pull request, right? And what's important to know is that a branch can have 0 or it can have 1 pull request. You wouldn't see a branch with 2 pull requests unless it's like the first one was, closed or deleted and then you're recreating it, right? And that's because a branch with 0 pull requests is probably a branch that's like still active or still under development. But a branch with 1 pull request basically is another developer or you saying, hey, I'm done with my branch. I want to merge those changes back to main because I'm done. Now, a pull request, we say it's GitHub's pull request because it's not part of core Git. Git has an idea of merging, but it doesn't have this idea of pull requests. But pull requests are a very good idea. So things like Azure, Bitbucket, and even GitLab all have this similar pull request functionality. They copied it from GitHub, or they came around the same time. I'm not going to go on record and say GitHub was the first to do pull requests, right? But it isn't part of core Git. But everyone uses it, especially like the website side, and it's because it offers a good chance to review. So we're going to talk about we can comment on it. We can like do things to accept or reject a pull request, and it also kind of logs the work done. So the commits to that branch appear in the pull request. So I'm going to go ahead and go back to the demo, and you notice GitHub is kind of giving everything away because I noticed I made a commit.
Emil, sorry. I think stop sharing your screen and reshare. Yeah,
Oh, no.
it froze again in the slides here.
Okay, cool.
Okay, yeah, you're good.
Okay, so hopefully everyone was able to see the last slides. I've now just I'm gone back to GitHub because we're going to show what a pull request is. And you notice that GitHub is making things easy. So I can go click new pull request, or I can go ahead and just click the compare and pull request button here. And also, again, please follow along. So when I go over here, there's a few kind of tricky bits that happen because we have a fork. The first thing is that I need to choose the base repository. Remember that this Git and GitHub Winter 2023, that's a fork that I created. So when I create a pull request, I could say, hey, do I want to make my changes? Do I want to merge my changes back to my fork? Or do I want to merge my changes back to their original? So I'm going to choose E. Harvey. I can even choose a different fork. So I see one of you is following along, which is great, but I won't be evil. So anyways, I chose as the base to be my repository, and you notice I kind of changed the UI a bit, so it's a lot more clearer. And I'm going to choose the main branch, and this arrow. So the base basically means like the original branch, like what's the 99% of the time it's going to be main. And the compare, it's like the branch that has the new changes, which is the add text file. So I'm going to go ahead and create a pull request. notice over here on the right, there's a lot of really cool things. So for example, I can choose an assignee or something. But there's also reviewers and all that kind of cool stuff. But those are fun things to explore on the side. What we'll do instead is create the pull request. And now this is a nice link. So what will often be when I'm like working on a project is I made the pull request, copy that link and drop it in Discord. And it's like, hey, everyone, like, please look at this and approve and whatever. Otherwise, I can see kind of a lot of information. There's a conversation bit, so I can add comments and blah, blah, blah. I can look at the commits themselves. Checks, this is a kind of automation side. So in a future workshop, we're hopefully going to talk about like checks you can do from GitHub. So imagine like unit tests and stuff being ran, and then this check will give you like a thumbs up or thumbs down kind of thing if your unit tests pass. And then this file changes. And then from file changes, you can even like create comments and stuff. So if I say like nice hello world, I can start a review, which is a whole process, or I can just choose to add a single comment. And yeah, you can see that it even comes up here. And it's really nice because you can like highlight code and be like, hey, what's the point of this function? Or like, uh, do other reviews, or like if it's your boss, right, they can be like, hey, like this code is not as efficient, or it's not meeting our style guide or whatever. So it's very useful for reviewing, and you can just resolve that conversation as well. So that's all like a quick dive in the features of the pull request, but usually the point of the pull request is to close it. And you can close the pull request here. This close is red because it means that you're basically rejecting it. So if someone really didn't like what I did and they're the reviewer, they can say, okay, we're going to close it because your changes weren't good enough. And you can reopen it later, but this is kind of the no, did not pass kind of scenario. What you want to happen is to merge the pull request stuff, right? The big green button. And clicking this button will take your changes and merge it into the main branch, right? So this information here is just describing how this merge is going to happen, specifically in this different kinds of merges. But on GitHub, the default kind will create a special commit, basically saying, "Hey, merge request happened, or pull request happened." And so this is the title and some comments for that pull request. And usually it's fine to just leave that as is because it's pretty informative. But anyways, otherwise you can click confirm merge and it'll merge the changes, and it says it's been successfully merged, and it's even closed it, right? Because it's all good. And it even asks if you want to delete the original branch, right? And it's fine to delete the original branch because all of the changes from this branch has been merged onto the main branch, right? So then if I go back to GitHub desktop, I'm still on this branch. One thing you'll notice is that like you won't ever delete branches locally. So it's kind of a bit of a nuisance. But if I go back to the main branch, what you'll notice is I might have to click fetch origin first. But you notice that there's been two commits. So there was a commit I made and the commit GitHub made. But basically, the main branch has been updated because my pull request was successful. And that pull request, again, just to be clear, had one commit, which makes up half of these two commits from origin main. The other commit came from GitHub itself, basically saying, and I'll just show you. It's the easiest. But if I go to history, you can see this is the commit I did that was what I created, and it just says, hey, I created this text file. And then GitHub made this merge request. It made it under my name, so it's kind of misleading. But it's basically kind of the same thing. It just reflects all of the changes from all of the commits, basically. So yeah, that is what a pull request is. So what you will want to do, just to be super clear, is create a branch, work on it for a short amount of time, create that pull request, drop the link, get everyone to approve it, reject it, whatever, close it, hopefully merge it, and then repeat that process, right? It might sound tedious, right? Especially if you're used to just working fast on your own, but it is very useful and it helps with like the traceability and making sure everyone's on the same page and has a chance to see what you've done. Yeah, that's how to use Git. I'll pass it back off to Gavin to talk about other tools to use.
Awesome. Thank you, Emil.
Mhm.
Yeah. So now, if you followed along there, you're pretty much going to use Git and GitHub and Bitbucket and Azure, predominantly in the way that we've shown you with the committing, the merging, the pull requests, like all that stuff. Like 90% of the time, you're probably going to use it like that. Um, so, which is awesome. You're now pretty much experts in Git. Yeah. So we also wanted to include some tools that GitHub provides that might help you with your projects. Um, and we'll also show you something that me and Emil and our other core team member Sanjay are working on the side as an example. So projects is the first tool we wanted to mention, and it's sort of like a place or it's a place where you can build like to-do lists and charts, some diagrams to add like tasks and stuff. There's like a Kanban board and everything. If you're familiar with like Trello, or I think Microsoft in Teams, they have like a boards app as well. Very similar. Um, Emil, do you
Yeah.
want to show them? Okay. Yeah.
Sure. Yeah. Sorry.
We'll go one by one.
Cool. Okay. So yeah, I'll show our one of our repositories. Really do lean into these task management stuff because
Mhm.
projects move so fast that it's so easy to lose information, especially like really critical like how tos or like decisions, right?
Yeah.
Um, on top of that, it's very helpful to plan projects, right? I've been in so many projects, and I might be on a project this term where I'm not planning enough and I'm going to fall behind. So this is GitHub projects, and you can see it's kind of like a task table. You can do a Kanban, and there's a lot of configuration. So like, for example, this is for a specific sprint. Um, and then my favorite one is this is very new and it's honestly all I use now is the Gantt board, where you can see kind of and like plan like how you're gonna meet your deadlines, right? And see what you're gonna do in the future.
Yeah.
Um,
Yeah, it's really cool. The next one is the wiki. And so if you're unfamiliar with what wikis are, it's really just like a place to save documentation or notes, ideas, brainstorming, all that stuff in sort of like a central location. It's a little bit different than like from Google Docs. And in my opinion, wikis are a little bit better. They tend to have like more features of like building like subcategories, um, and they also allow for markdown as well. All these tools actually allow for markdown. If you're unfamiliar with that, it's like a way to stylize your text and fields, just to make it more readable and have like titles and like tables, to-do list, all that kind of stuff. Yeah, do you want to show them our wiki?
sure, yeah. So we also have a wiki. Um, it's very basic, right? Like it's just like a page to store stuff. But you can see you can do things like tables and a code snippets. And it's very easy to insert images. So like we have a lot of diagrams and stuff. Yeah, so very useful. What I find is like if you have any sort of group project or stuff like that, sometimes it's nice to just take whatever you did for like a submission for that and then copy and paste it into the wiki, especially if it's like design related. Um, because otherwise it's so easy to lose them, and it's nice to refer to something rather than to have to ask someone to like
Mhm.
give it back or something. It's so easy to lose information.
Yeah. And
Yeah,
even if you're unsure or if it's not the final design, like push that into the wiki. That way you're able to go back and be like, oh, we're scrapping this idea, or oh, we're going to build off on this idea. it is a very useful tool.
Mhm.
So the last one is issues, which I would really emphasize you using. And contrary to what it's called, it's not just for bugs and like code issues, but you can actually use it for more task management style stuff. So in our project, we have it essentially just like task related things or features that we want to implement. Um, and this is actually how a lot of repos and stuff like uses this issues. So you gotta sort of ignore the name and think of it more like a task and that sort of thing.
Yeah. Yeah, I really recommend using issues. I have a repository, like a project now where all we have is issues and we don't even have any code. Um, but it's very useful. And you can do things like really think of it as like a to-do list. Um, so like lots of like you can have design things. I like to use it for research because it's kind of like I have like a task here. And I'm like, oh, I got to figure out this crazy thing that I want to do. And then as I learn more about it, I can put little comments to be like, hey, here's something I tried. Here's the result. Or like, here's like a summary of like what I found. The one thing I'll highlight kind of at the end is the issues, the projects, and the wiki. They all have pretty good integration with each other. So you'll notice here that for this issue, it says it's tracked by 12, and that's because in this issue, which is number 12, you can see that I kind of set up a to-do list, and then in terms of the what I've actually typed as text, I just this code is like markdown, blah blah blah, for making a to-do list, but this number 21 is just like the ID of that issue. So like if I go to this issue, you can see like the URL is just issues/21, right? So this is like the ID of it. So yeah, so there's a lot of integration and like you can link things together, and it is very very useful to do so. It sounds like extra, and it sounds like, well, I could just like whip out the project myself if I wanted to, and that's probably true. But the moment you add another person, like there are so much that you will be talking about and so many decisions that you're going to be making, that there's no possible way that you will like both have the same idea of what's going on um, at once, right? So the issues is very very useful. um, is there anything that I'm like maybe I should emphasize or talk about more, or anything that you want to talk about, Gavin?
Could we click on maybe one that has both of us talking on it or something? I don't know if we do. Sure, click that one.
Sure. I think I might have. Oh yeah.
Added some stuff. Yeah, so similar to the pull requests and pretty much literally everything else in in GitHub, you're able to have like conversation. Two or plus more people can like comment on a single issue or a task or a pull request or even a piece of code. Like it's crazy. Um, and again, like we can push like images and stuff here too, as well as like add in other people to chime in and set tags and stuff too. So it's all integrated, all really cool. Highly suggest you like get into sort of the practice of using this as a communication tool, because you're able to do it uh, like you're able to integrate a lot more things and have like good traceability, rather than like on Discord or something you might have to scroll up a lot or um, search, and it might not be sort of what you're looking for. So yeah.
Yeah, definitely. Yeah, don't like I love Discord, but don't rely on it because you will be like I'm in a few groups this term, and we have 4 members, and I'll mention like one thing like, hey, reminder that there's a meeting today, and then there'll be like one other subject that we're talking about, and nobody's coming to the meeting because it was buried, right?
Yeah.
Um, the other thing, like while we're on the topic of issues, is issues are a great thing to look at if you're like looking at like say a Python library that you want to use, or just like someone else's project, right? Like software libraries is a really big one, because you can see like, say it's a like Python library and it's not working for you. You can see if someone else has the same problem. It's kind of like Stack Overflow, like as a backup. So if you're not able to find your answer in Stack Overflow, like a GitHub issue might have it. Or if you're like evaluating, hey, is this library any good? And you see a bunch of issues being like, hey, there's no updates and nothing is working and blah blah blah, right? Then you can kind of save yourself the trouble. So yeah, cool.
Awesome. Now, I know that this was sort of like a shorter workshop than what we usually do. But is there any questions or anything we can help you out with? I know it might take a minute or two to type.
Yeah.
Yeah. Awesome. Thank you for coming at the very least. Hopefully you found this at least a little bit informative. As a sort of update on what is happening over the next couple of weeks in the club, I believe next week we're trying to do a interview workshop. I think.
Mhm.
Yes. Okay.
Yes.
That will be coming online, or like coming into our portal, I should say, in the next like little bit. And then that's probably it until after Success Week. We're going to try and keep it a little bit lighter because of exams and everything. But yeah, hope to see you at least at the interview workshop.
Yep.
Awesome.
Yeah.
If
Awesome.
there isn't any questions, which I don't think that there is, we can call it a day here. Yes. Thank you so much
Mhm.
for coming. Have a good
Yeah.
night.
Yeah. Good night, everyone.